Well, we're up to Unit 12 now, and in this unit we will be introducing you to a new strategy, and this strategy is called conditional proof. Conditional proof is going to be your friend, really, because the proofs so far that you've been doing are about as long as they're going to get. In other words, conditional proof will really shorten some of the problems, making them a bit easier. So, let me talk to you a bit here about conditional proof as a strategy. Conditional proof applies really when you want to ultimately get any sentence of a conditional form, such as P hooks Q. When you want to generate such a sentence, you may begin by taking an additional assumption beyond those that are given as the premises of the argument. And this additional assumption will always be the antecedent part of the conditional you're trying to generate. So in this case, we must assume P. Now the strategy behind conditional proof is this. We're going to make the additional assumption P and show that when we do that, we can in fact conclude Q. We're going to conclude Q from P inside what's called a subderivation. The subderivation alone shows you that Q in fact does follow from P, so it will look like this. From some number of steps after our assumption P, we will be able to derive Q. Now notice what this shows us is that Q follows from P. Or another way of putting it is that if P is true, then Q is true. So you can see then that the subderivation's validity allows you to pull out or discharge onto the outside line of derivation a sentence of the form P hooks Q, the conditional. So anytime you want to prove either a conditional sentence or anything which is equivalent to a conditional sentence, this strategy will be applicable. It's obvious then that any problem which has a conditional as its conclusion is going to be ripe for this kind of strategy. So the first couple of problems here will be attempting to use conditional proof. Remember, too, as I've just pointed out, that a valid conditional proof always will discharge the subproof. You will come out, as it were, from the indented part of the proof onto the outside left-hand line of the proof. So let's see how we can do with a relatively easy problem. When you notice that the conclusion that you're trying to get is a conditional, you then think to yourself, well, conditional proof applies. If I'm going to use conditional proof, of course, I need to decide what assumption I'm going to take. Here's a little rule of thumb. The assumption is always the antecedent part of the conditional you're trying to generate. Now, there's a very common mistake that students originally make when they attempt to use conditional proof, and that is to attempt to take the antecedent of one of the premises. If we were to take not B here, notice that wouldn't give us the kind of answer we're going to be looking for, because according to the rule of conditional proof, that would then generate a line, ultimately, that had not B as the antecedent. Not B would hook something. And of course that isn't what we're after. We're after a conditional that begins with not A. So the first thing to do on line 3 is to take the assumption not A. With that on board, you can see conditional proof is powerful because it in effect gives you something else, another element to work with. So having not A, we can clearly get not B from line 1 by simply invoking modus ponens. We need to put up here, of course, assumption, conditional proof. And the not B we get from line 1 and line 3 by modus ponens. And now, of course, we have what is the antecedent of line 2, so on line 5 we can invoke modus ponens once more and get our not C. And that, again, is line 2 and line 4 modus ponens. And now look at what we've done. We have started a subproof which has gone from not A to not C. It's at this point that we can discharge the subproof to give us a line which is equivalent to the conclusion. So out we come, and remember, the only way to discharge a conditional proof is with a conditional sentence whose antecedent is the assumption and whose conclusion is the last line of the subderivation. Now we're on the outside derivation line and the problem is finished. Okay, now this strategy really works the same all the time. In other words, you have to have as that assumption for the conditional proof subderivation the antecedent of the conditional that you're trying to get, and you must go through a set of steps that leads to the consequent of that conditional, and then you discharge, close off the subderivation with this conditional line. All right, let's do a slightly harder problem. Here we have only two premises, and notice once more we have a conditional as the conclusion. So immediately you should think, I can take advantage of conditional proof. To do that, I would need to take the further assumption, which again will be K in this case, because that's the antecedent of what I'm trying to prove. And we cite assumption conditional proof. Now I ultimately have M as the goal sentence of the subderivation. So how am I going to get M? It must come out of line 2, and I've already got K. I can get M from line 2 if I can get K and L. And of course I can do that because line 1 allows me to get L via modus ponens. So we can get our L by lines 1 and 3, modus ponens. Now we have K and L simply by 3 and 4, conjunction. And now we need to get the M, and that's of course straightforward because simple modus ponens on line 2 will give us M, lines 2 and 5, modus ponens. And now a subderivation beginning with the antecedent K, ending with the consequent M, and so we're ready to discharge onto line 7, K hooks M. And we cite, of course, the whole subderivation, 3 through 6, conditional proof. All right. Now we will do one with a couple of more premises and a little bit more complex conclusion. Notice the same principle is going to apply, however, and when we move to this problem, you'll see that the antecedent is a conjunction. We have here M and not P hooks S. And so applying the same principle, what we need to do is take the entire antecedent, the M and not P, as our assumption. And of course that's going to be a very powerful move to make because that will immediately give us both the M and the not P to work with. M and not P, and we cite assumption conditional proof. Now we undoubtedly need to break this up so that we can avail ourselves of both the M and the P separately. So let's do that. We'll get line 5 from 4 simplification, and similarly a not P by line 4 simplification. Now what are we hunting for? Our goal sentence now is the S. And so we look through the premises and find out that S occurs here in line 3, and that's its only occurrence. So we're going to have to get into line 3 here in order to get the S. Notice if we were able to derive S or P, since we already have not P to work with, disjunctive syllogism would give us the S if we had N hooks R. So how are we going to get N hooks R? Well, notice that the relationship between lines 1 and 2 comes into play here. We have N as the antecedent of this internal conditional and R as the consequent of this internal conditional. And of course hypothetical syllogism would be possible on lines that look like this, N hooks O and O hooks R. So if we can get into line 1 and 2 by modus ponens, we will then be able to use hypothetical syllogism on those inside components and ultimately get N hooks R. So line 7, of course, we have the M from line 5, which will allow N hooks O from line 1 and line 5. modus ponens. Now we need to get into line 2, but we have the not P, so that's just a matter of modus ponens once more, and we cite lines 2 and 6, MP. And now we have our 2 lines that allow for hypothetical syllogism. And notice now I'm still doing all of this inside the subproof because we ultimately need to have a final line there, which is S. So we haven't yet gotten there, but we're on our way. Now we get n hooks R by 7 and 8, hypothetical syllogism. And now we've got the antecedent of line 3. So of course S or P is gotten with 3 and 9 modus ponens. Notice at this point too, another part of conditional proof, we can bring in line 3. We can work on line 3, as it were, inside the subproof. That's fine. You can bring information into the subproof. But the only way that you can close off a subproof, discharge it, is to ultimately get the consequent of the conditional which we're hunting for. And we're almost there. We simply need to notice not P up here at 6. That negates the P in line 10, and so that gives us our S by 6 and 10 disjunctive syllogism. And now we have what we were looking for, and so we can discharge out here and complete the proof with M and not P. Remember, that's the assumption that we've taken. Hooks the last line S, and that's our conclusion. And so we cite here the entire series of lines, 4 through 11, the whole subproof, conditional proof. Okay, not too bad. We'll do one more, and then we'll do a translation of an English argument. So here's 4. Notice this is going to be a little bit more interesting problem because the conclusion is not only a conditional, this is the main connective, but once we've taken that assumption, what we'd have left over to use as our goal sentence is also a conditional. This is the situation where you in effect do 2 conditional proofs, one nested into the other. So again, this is a very powerful way to be able to solve what otherwise looks like a pretty difficult problem. Let's begin step by step now. We want to assume the F. That's the antecedent of the conditional we're hunting for. And so that is assumption conditional proof. Now notice at this point, since we have taken the F, we want to get this conditional, we're at the situation where we can say, but look, what we're hunting for now is this conditional. And so, anytime I'm hunting for a conditional, I can take as an assumption its antecedent. To do that, I have to indent once more, and so line 4 comes in again, relative to line 3 there, and we take the not H as another assumption of a conditional proof. And so we're going to have one subderivation nested inside another one. Now we've got F and not H to work with, and now the goal sentence is simply the J. So by whittling away at this conclusion, that's how the strategy of conditional proof has power. So we've got all this to work with, and we're hunting for J. And we look around and see, of course, we've got J here, and we've got J here. So we know we're going to have to manipulate line 2 in some way in order to get the J. Well, what do we need to do on line 1 to help us out? Well, we've got F, so clearly we can have F or G just by simple addition, and therefore we can get H or I. That, of course, will help, since also having not H, disjunctive syllogism tells us that we can have the I. We can conclude I. And that will help because with addition we can have I or J, therefore getting into here. We've got the F, so modus ponens will allow us to get this J. So the J that we're actually going to derive is this occurrence of it right here. Now, that was a little fast, so let's go a little bit more slowly and see how that works. We first want to generate F or G in order to use modus ponens on line 1. That's simple. We have already got the F, and so we cite line 3 and addition. And so we have H or I from line 1 and 5, modus ponens. And now we have not H and this disjunction, so we know I to be true by lines 4 and 6, disjunctive syllogism. Now we simply need to add the J to the I, and that is simply line 7 addition. And now we can operate on line 2 with modus ponens to get F hooks J. That's line 2 and 8, modus ponens. And we have the F. Remember, you can always bring information into the subderivation, so we can take advantage of the F and get our J. And that's by 3 and 9, once more, modus ponens. Now notice, here's where we have to be careful. We've got this internal subderivation from 4 through 10. We need to discharge that, and what we will get then is a line 11 which occurs under 3 and which is generated by the assumption that we took on line 4, hooking our last line J. And of course the reason we want that is that we're trying to generate this part of the answer. So that discharges the internal subproof, and we cite 4 through 10 conditional proof. But we're not done. We still need then to discharge this subproof, because you're only done with a conditional proof strategy when you ultimately get back out to the outside line. And so once more we come out, line 12 comes out again, and we now get the conditional that's composed of F, this assumption, as its antecedent, and the last line of this subderivation, which is line 11. Okay, and here we cite lines 3 through 11, conditional proof. And now we're done. So you see how this strategy can be folded into itself, so that actually very complex conditional statements that have more than one hook in them, can be taken apart, as it were, with the additional assumptions that you make for conditional proof. Okay, now we're going to take this strategy and, as we have done in earlier units, apply it to an English argument and attempt to first symbolize and then create a derivation using conditional proof of the conclusion. So we need to translate the following English argument into symbolic form and use conditional proof in a deduction that derives the argument's conclusion. If money is the source of all happiness, then one is both selfish and ignorant of the truly valuable things in life. But if one is either selfish or ignorant of the truly valuable things in life, inner peace is impossible. It follows that if money is the source of all happiness, then inner peace is impossible. All right, well, that sounds valid. Let's show that it is first by symbolizing. And here we've got it follows that. That's the conclusion indicator. So we know that this is our argument's conclusion. Let's begin with the first premise. If money is the source of all happiness, then, so we've got a conditional statement here, one is both selfish and ignorant of the truly valuable things in life. So we have a complex conditional whose consequent is itself a conjunction. The both and shows the conjunction. Now let's assign some letters. If money is the source of all happiness, we'll let money is the source of all happiness be M. And then we need a letter for one is selfish, that'll be S. And one is ignorant of the valuable things in life, let that be I. So the first premise then will be if M, then both S and I. Now our second premise starts with but, and you'll remember that's logically equivalent to and, so that's simply connecting this next sentence with our first premise. It just indicates that it's the second premise. So the real connective, the real main connective of the second sentence here is again this conditional if one is either selfish or ignorant. So we have a disjunction inside as the antecedent of the conditional, and then we have inner piece is impossible as the consequent. So one is selfish or ignorant is, you'll remember, one is either selfish or ignorant, S or I. And if that's true, so we need to have a hook here, if that's true, then inner piece is impossible. Well, we're going to have to let P stand for inner piece. We don't want to use the I, since that already stands for ignorant. And now we've got both premises done. We need our conclusion. It follows that if money is the source of all happiness, then inner peace is impossible. A straightforward conditional whose antecedent is M and consequent P. All right, now we have here a conditional sentence as our conclusion. So once again, we think to ourselves, conditional proof is the strategy that we can take advantage of. And to do that for this problem, we would need to take the assumption M. Now, how does that help? Well, of course, we have a conditional that begins with M on line 1, so we're going to be able to get S and I from 1 and 3 by modus ponens. And that helps because that gives us S by itself, simply from line 4 and simplification. That will generate S or I, right, by line 5 and addition. And now we have the antecedent of the conditional on line 2, so we can do modus ponens and get P, line 2 and 6, modus ponens. Now we're done with the sub-proof. We've started with M, we have derived P, and so we're ready to discharge on line 8, getting M hooks P, and citing 3 through 7 conditional proof. Okay, that is it for Unit 12. I told you this would be relatively easy, and I think you'll notice as you move on from here to the very last unit, 13, that introduces indirect proof to you, that once more you have an additional new strategy which in effect shortens the proofs, makes the whole thing a little simpler. So you're really over the hardest part. Good luck on the last unit.